everyone. Today we're gonna talk about how to calculate duct weight. So focus with me, and by the end of this video we are gonna learn an easy way which is gonna make our work is easy, especially for those who are working on quantity surveying. So first of all, we have here a project which contains systems of ducts, different systems. We have supply air ducts, return air ducts, exhaust air ducts, and fresh air ducts. So we are gonna need to create a new schedule. So we are gonna go here to schedules and quantities, and right click and select new schedule, and we are gonna filter on mechanical, and now we are gonna go to duct. So we are gonna choose ducts, and let's name it like duct weight schedule. Duct weight schedule. Click OK. Okay, we're gonna choose some fields which we're gonna need, and by the end of this video you can choose which fields are useful for you. Of course, we have some fields we can't ignore them, but the other you can filter by the family and types. You can filter by the systems. You can choose whatever you want. Okay, now for me, I'm gonna choose system type. Okay, and I'm gonna choose family, and here are some parameters we are gonna need to use, like width. We are gonna choose width, and choose height, choose length, and also choose area. Okay, we're gonna need this. It's an important field we are gonna need, and click OK. Okay, now we have duct weight schedule. Okay, if you look at this, we have here the area in a square meter, but you can see there is some areas equal to 0 because the area is so small. So we are gonna choose, we are gonna choose format and unit, and we are gonna choose square meters, of course, but we are gonna make it 2 decimal places. Okay, now you can see the area, the areas which was equal to 0. It was actually equal to 0.43. Okay, now we created this schedule to calculate the duct weight. We need to know what we're gonna use to calculate duct weight. The duct weight is equal to the volume multiply the density, and to get the volume we need to get the area and the perimeter. We have here the area, and we need to get the perimeter. So now we're gonna create a new function. Let's call it perimeter. Okay, and it's common, and of course it's length. Okay, now the formula, it's gonna be 2 multiply width. Okay, or I'm sorry, we're gonna use here an arch, plus height. Okay, and click OK, close the arch, click OK. Now we have here the perimeter. Okay, we are gonna make it the perimeter. Choose the format unit in millimeters. I'm gonna choose 2 decimal millimeters. This is the perimeter. Okay, now we need to calculate the volume, but the volume is equal to the area multiply thickness. And to calculate thickness, it's like not a big deal, but we know we need to know about a code called SMACNA code, which uses something called gauge. The gauge is in the ducts, which a function in thickness. So we are gonna go and see. Okay, now as you can see in this code, we have here some values for the gauges, and the values which like we can use in the gauge. for the thickness. And for the gauge 26, we can see the thickness is equal to 0.47, and for gauge 24 the thickness is equal to 0.64, and for the gauge 22 we can see the thickness is equal to 0.79, and for the gauge 20 we can see the thickness is equal to 0.95, and those are the most gauges we use. Okay, now we can write them on a side note or something so we can always remember them. And now we are gonna create a function for the thickness. Okay, we are gonna go here and okay, I'm gonna create thickness, and the thickness is also a length, so we are gonna use this length. And here is the first problem we are gonna face: how to write these values in a formula that is applicable. We are going to use if condition, and if you know the if condition we use, we are gonna type if, and the condition we want then true or false. So we are gonna type all of the conditions we have here for the gauge 26, 24, 22, and 20, and then we write the last condition, which is false. So we are gonna use if and open arch width, because it's a function in width, smaller than 300. So, and then comma, we're gonna type the first value we have here, which is 0.74. so we're gonna 0.74, and then another comma, and we are gonna take this, copy and paste if, but now we are gonna change this, and it's gonna be equal to 750, and the value of the thickness, it's gonna be equal to the next value, which was 64. Okay, so we are gonna type 64 and another paste. Okay, now the value is, if the width is smaller than 1350, the value it's gonna be a 0.79, so 0.79, and in this condition we are gonna use if width is greater than, okay, I'm sorry, I'm gonna type greater than 1350, it's gonna be 95, the last one. Okay, as we can remember. And for the false condition, we are gonna just type 0. Okay, now we need to close all the arcs, but how many arches we have? Okay, we can calculate them. This is 1, this is 2, and this is 3, and this is 4. So we have here 4 arches. We are close all of them, 1, 2, 3, 4, and then click OK. Okay, case sensitive. Oh yeah, okay, we need to be a case sensitive. So if we have here width with bigger upper W, so we need to use upper W. So we are gonna go for every width and make it uppercase. Okay, so, and this is click OK. Okay, now we have here the thickness. Okay, of course the thickness is in millimeter, but you can see it's all either 1 or 0, because we didn't use the format units. Okay, no, we don't need to save, it's in millimeters, but we are gonna choose 2 decimal places, choose millimeters. Okay, as you can see, now we have here all the values. the 64 and 47, 64, 47, 64, 47, and here is one, and if you can see, the width is 800, so it's 79. Okay, we are not gonna find here the value, which is 0.95, because we don't have here in the project a duct like in this width. But okay, we are gonna create one. Go to systems, select duct. Okay, okay, the middle elevation, we are gonna make this like a 1400, and okay, it's a return duct. Remember this, because we are gonna need to see if it's there or not. Okay, we have it here. A return duct. The width is 1400, and the thickness is 0.95 millimeters. Okay, this is what we have now. Now we have the thickness. We need to calculate the volume. The volume is equal to area multiply thickness. So we are gonna create one. There is here volume. No, there is no volume. So we are gonna create a function called volume. It's common. Yeah. Okay. Now it's volume, and we are gonna choose area multiply thickness. Okay, click OK. Okay, and here is the volume. Okay, now you can find that the value is near to 0, but why is it? Because it's in cubic meters, and it's around two decimal places. Okay, I'm gonna show you something. If you make it for cubic millimeters and we choose 0 decimal places, okay, now you can see the actual volume, but we are not gonna use it in cubic millimeters. We are gonna use in cubic meters, so we are gonna make it cubic meters, but we are gonna round it for 3 decimal places and click OK. Now you can see the volume of each duct. Okay, this is 0.004, 0.001, and etc. Okay, of course, the ducts here are so small, so the volume is small. You can see the width is 400 and 400, 300 and 400. It's in millimeters, so basically it's so small, but you can find the volume is bigger in bigger projects, not in this volumes. Now we have area, perimeter, thickness, and volume. So to calculate the duct weight, we said in the beginning of the video, we need to know the volume and the density. Now we have the volume. How to get the density? We are gonna create a new function, a new parameter. We are gonna call it density. Okay, it's common, and it's mass density, and it's of course an instance parameter, because we are gonna assign it. Okay, yeah, I used it once before, so we are gonna make it density 1. Okay, call it density 1 because I created one before. You can find it here. This is a created parameter. We can delete this, and yeah, you can delete this. You can create one from beginning, call it density, and we are gonna choose mass density and click OK. Now we have density. Okay, if you look here at the table, you can find the density is an empty. It's an empty schedule. How can we fill it? Okay, for the galvanized steel, the density is almost equal to 7,850 force kilogram over meter over cubic meters. Okay, to decimal places. No, we need it just 0 decimal places. it's a correct number. And how now to make this for all of the ducts? Okay, now we are gonna go to sorting and grouping, and we are not choose itemize every instance, so we're gonna click OK. Now you can type the value and just leave it like there and go back and choose sorting and grouping. Okay, you are not gonna choose itemize every instance. Now we have the density for all ducts. As you can see, all the ducts have the value of the density. Now we have here all the parameters we need. We have length, area, perimeter, thickness, volume, and density. Now to calculate duct weight, all we need to do is to type the formula which we need to calculate the duct weight. So we are gonna create a function, call it duct weight. And okay, here is another problem. If you search here for a kilogram, you are not gonna find a kilogram because the duct weight is in kilogram. So you need to like search for a kilogram. For a mass, you're not gonna find the mass. You're not gonna find the kilogram. Go to HVAC. No, there is. I'm sorry, there is no kilograms here. There is no mass here. Go to electrical. You are not gonna find anyone. Go to piping. Also, you're not gonna find anyone. Okay, so we are gonna go to structure, and we are gonna use mass. But to have a kilogram in the result, what we can use here from the formula to have a kilogram. Okay, if you multiply volume by thickness by density, I'm sorry, you can have here a kilogram. Click OK. Now you have the duct weight in kilogram. Okay, oh, voila, here is the duct weight. Now you have the duct weight for each duct. What you need to do to have the total weight for every group of duct, like I said in the first in the beginning of the video, we use here I use here the system type. I need to know if there is supply air duct or return air duct or fresh air duct or exhaust air duct, exhaust air duct, and you can choose whatever filter you need. But the concept is one. So we are gonna go to formatting here and choose duct weight and choose calculate totals. Okay, we're gonna go back to sorting and grouping. I'm gonna sort by system type. I'm gonna choose footer and calculate grand total. Okay, click OK. Now you are gonna see. Okay, make this smaller so you can see. Okay, he started with exhaust air. You can see the calculate the total weight of exhaust air, and which the number of them is 38. The total weight is 247, and for the fresh air duct, and which is 64 item, you can see the weight is 518, and for the return duct, which number is 11 items, the weight is 432, and for the supply air duct, you can see their number is 128 item, and the weight of them is 1777. I'm sorry, and the grand total for all the duct systems, for all of them, is 2,975. Okay, this is how you calculate the duct weight. This is a simple way. You can, from this, calculate the duct weight. You can use it in quantity surveying. It's gonna make it's gonna save you a lot of time, and you can apply it in a lot of situation and a lot of projects. I hope you enjoy the video. I hope you have fun with me, and wait for me in the next videos, and goodbye.